we are back with a challenge. This time it's about electrical cables. Here we have an electrical cabinet to simulate the wiring of an industrial machine. These that I have in my hand are cable glands, and they are used to insert the cables into the electrical panel, securing them firmly.
I, on the other hand, have this in my hand, which is a modular cable pass-through system. Let's try to work and see who will end first.
3, 2, 1.
I'm done. I'm done. Finished. It seems like a good job for being practically the first day of my life that I try to wire a panel. So, as expected, I finished first and even helped Stefano. But now let's understand why and how these two systems work. In industrial machinery, the number of cables to manage is significant, from the power supply to the motors, the signal cables of the sensors, and the various devices present.
The cable gland is one of the most used tools. It is a small mechanical component that is used to fix and protect an electrical cable when it enters a panel, a box, or a machine. It works in a simple but effective way. The cable passes through a hole, and the cable gland, thanks to a rubber gasket and a screw system, tightens around the cable when screwed.
This, on the other hand, is a modular cable management system. Let's see the differences.
When we use a cable gland, each cable needs its own hole.
But really each one, as you have seen?
Exactly each one, yes. You insert the cable gland into the framework, you screw it in, you pass through the cable, you insert any possible gaskets, and you eventually seal everything with a cable gland nut. This system ensures sealing, but it has some limitations. First, a hole is needed for each cable, and you especially can't pass cables that are already headed.
This system, on the other hand, developed by Detas, uses a modular frame that can accommodate multiple cables in the same drilling. Thanks to elastic membranes or openable inserts, it is possible to pass cables of different diameters, even those already headed, without needing to disassemble them or remake the connectors. Look here. The system consists of openable TPE grommets in which cables of various sizes can be inserted. There are many other types to suit every need. Once the layout of the cables is studied and decided, the grommets are inserted into a polypropylene frame reinforced with fiberglass, which allows to reduce bulk compared to traditional cable glands, thus enabling neater and often smaller panels. Everything is then tightened with AISI 304 stainless steel screws.
And what if we need a special connector for one of our machines?
Well, the connectors can be integrated directly into the frame of the modular system, thus simplifying the wiring and connection operations. And this system is very useful, for example, in applications where it is necessary to disassemble and reassemble the machine, or to move it to the customer, or to mount optional or dedicated machine accessories for specific operations.
On the safety side, the UL94V0 class of materials ensures that the material self-extinguishes within 10 seconds in the presence of flame without producing flaming droplets that could spread the fire. These systems are then tested in certified laboratories where their resistance to water jets is tested, as you can see, quite strong. They have an IP66 rating and in some models, even an IP69K rating, which is the level of protection needed when the machinery has to be washed. The 69K indicates that a device is completely protected against dust and high-pressure, high-temperature water jets. In fact, the 6 in the first number indicates full protection against dust, while the 9K in the second number indicates protection against powerful water jets at 80 degrees Celsius and 100 bar pressure from a distance of 10 to 15 centimeters from different angles. Well guys, let's thank Detas, and I would say this is also engineering.